Hello, this is Arvind Sami from Artificial Intelligence and Data Science Department. Uh, my project title is a flow-based SDN intrusion detection using machine learning with the real-time alerts. So, let me give you a short introduction. Project is like a software-defined networking (SDN). She enables a centralized and programmable network control, but introduces security risk due to control centralization. Then, traditional intrusion detection system fail to effectively analyze the high volume dynamic flow based traffic in SDN environments. Then machine learning ML provides an intelligent and adaptive mechanism to detect malicious network behavior through automated flow analysis. So this project presents an intelligent SDN intrusion detection using supervised ML algorithms to classify network flows as begin or track traffic. The model we used is actually we compared by using four ML models, and we finalized a random forest model because it achieved the highest accuracy score of 91% in deployed in a Flask based web application supporting a real-time flow prediction and the bulk CSV log analysis. Then the statement of the problem, the centralized SDN controller acts as a single point of failure, making it high vulnerable to targeted cyber attacks that can disrupt the entire network. Traditional intrusion detection systems are ineffective in SDN due to the dynamic, high speed, and flow based nature of traffic. Then, rule based and signature based security mechanisms fail to detect complex, evolving, and previously unseen attack patterns. Objective to design an ML based SDN intrusion detection system that accurately detects malicious traffic in real time and provides automated alerts for fast response. Then the scope of the project: design and develop a machine learning based intrusion detection system. So our project scope is to develop a machine learning project which can predict the attacks uh, by using uploading whole company CSV logs or in-person logs also. It can store all prediction results securely for monitoring, analysis, and auditing purposes. Yeah, then a fully functionable SDN IDS web application with user modules for flow prediction, CSV upload, admin dashboard for analytics and monitoring, real-time alert notification. These are the main functions we have. The data, then the data flow based SDN traffic data consisting of attributes such as packet count, byte count, duration, source and the destination address and protocol details is used for training and testing the intrusion detection models. A labeled dataset containing multiple attack types and normal traffic is utilized for supervised learning, enabling the system to learn attack patterns and perform accurate classification. Limitation: the system relies on static datasets and it does not include a real data streaming directly from operational SDN controllers. Then the methodology, what and all we have is data collection and pre-processing. We are collecting the data from by CSV log or separately from the single users. Then future selection and extraction. Then model training using supervised. We are comparing by four models: random forest, SVC, logistic regression, gradient. These are trained, and random forest gave highest accuracy, so we choose the random forest. uh, then optimal mode selection and evaluation: the model with the highest accuracy random forest is chosen for deployment. Web integration: the selected model is integrated into a Flask web interface, enabling users. So yeah, we have a web in, web application to access the project, like access our project by uploading CSV logs. Yeah, visualization and administration. Yeah. So we will give an admin panel presents charts and analytics showing attack distribution and prediction history in the whole. For example, if we be in a company, there will be for example 30 or 40 employees are there. There will be another employee 31st or 41st. We can keep it as a he will be having that panel to monitor this. Yes, then testing and validation. The system is tested using real world like flow logs. We also tested with the flow logs, user inputs to ensure stability and accuracy. So this is the architecture flow diagram. SDN Intrusion Detection System architecture. This is the user and this is the admin. User register and login. Admin logins. Web application authentication. There will be email alert. Then data collection, collecting the data, pre-processing, model training, model evaluation, deployment, scalar and model files. Yeah, finally, it will be in a database, stores and prediction. Then design use case diagrams. This is the where UML diagram, use case diagrams. A use case diagram, a graph of actors, set of use cases enclosed by a system boundary, communication associations between the actors and users, and generalized among use cases. The use case model defines the outside actors and inside use case of the system behaviors. This is the user and this is admin. Admin will be having the admin and login page, view analytic dashboard, and view all predictions. Users will be having view results, CSV log, upload, single flow prediction, login and register. Class diagram. User ID. This symbol will be used for user ID, email, password, register, login. Then for prediction, controller, admin, and ML model. User, flash controller, then sends future for prediction. ML model will be using it will be stored in database, predicted attack. So again it will come and store in database. The algorithms we used, actually we as I said, we used random forest classifier, support vector classifier, logistic regression, gradient boosting classifier, model comparison, final section. It will be like we compared all the algorithms and selected one according to the F1 score and accuracy. Hardware and software selection. In hardware, the processor, a multi-core CPU, Intel i5, i7 or AMD equivalent to efficiently handle model training, flash server execution and dataset processing. Memory, minimum 8 GB, preferably 16 GB to support ML computations, which can handle uploaded CSV files without lag. Storage, at least 256 GB SSD for fast dataset loading, model storage, and quick read and write operations record with application. Network interface, high speed network connectivity to support the web application access. Software, Python and ML libraries, Flash framework to upload CSV and admin dashboard functionalities. Next, database system, SQLite or MySQL for storing user inputs. Development tools like IDs like PyCharm, VS Code along with Git for version control and virtual environments. Implementation, data acquisition, collected a labeled SDN flow database, then data pre-processing, future selection, model training, training the model, then we are evaluating the model, random forest model, ML model, models serialization, the Flask web application development, database integration, and admin dashboard implementation. Imported code segments. The code we imported, firstly, we are importing libraries like pandas, NumPy, Matplotlib, Seaborn, SQL model. We are using train test it. Then we are using a pre-processing import standard scalar. We are giving all the needed libraries. These are the codes. This will be our output after we executing this code. We will be getting on a link to redirect. So it will redirect into this page. Firstly, we need to register. We need to register this. After that, we will be having that employee ID and password. So after we'll be having two pages. One is single flow prediction, another one is CSV log prediction. In single flow prediction, what we have to do is, for example, for first we'll go with CSV log prediction, which can be used for like if we are being company. Of course, I said 30 employees are working, all will be like interconnected, so all logs will we can get in single monitor, all 30 persons, so we can download it as a CSV log, all everyone's, so it is interconnected network, right? So we can download it and we can upload it as a CSV log prediction. In single flow prediction means if we are, for example, we are a single person working and we need this application, or we are doing work from home, but we need to check any attacks. We can We can upload our details in single flow prediction, so it can help. This is our home page. This is the prediction result after we uploading. See, top three probable classes DDoS. We will be feeding all the possible attacks, like six attacks, by analyzing the process, by analyzing the patterns. How I am saying is, all the attacks will be having some kind of patterns, which we are already feed into the data. For example, if this kind of patterns comes means this DDoS like attack like that, we already feed into the code. So according to that, it will analyze and it will give the result. Excuse me. This is a real time alert. If we get any attack in while operating means, it will give a mail link, employee ID, attack type, which attack, and all the details it will give, source, time, everything. This is the admin dashboard. See, this is the DOS attack, botnet, port scan, DDoS. These are the test cases. This is the accuracy point we got for a random forest model. So the conclusion: the proposed intelligent SDN intrusion detection system successfully demonstrates the effectiveness of machine learning in enhancing the security of software-defined networks by utilizing flow-based features and evaluating multiple supervised algorithms. The system identifies malicious traffic with a high accuracy, with random forest emerging as the most reliable model.